Welcome to example number 1. We're asked to find the mass in atomic mass units, U, for a carbon dioxide molecule. And we're also asked to find what would be the mass in grams of 3 moles of carbon dioxide. Hopefully you recall from your chemistry class that the mass of a molecule is very nearly equal to the sum of the mass of its constituent atoms. Hence, the molar mass of a molecule is equal to the molar mass of all of the atoms. And in carbon dioxide, we have carbon and oxygen atoms. The molar mass of carbon is 12 grams per mole, and this you can get from a periodic table. We also need to know the molar mass of oxygen. So the molar mass of oxygen is 16 grams per mole. So to find the molar mass of carbon dioxide, we have one carbon atom, but we have 2 oxygen atoms. So that's 12.0 grams per mole plus 2 times 16.0 grams per mole, and that will give us a total atomic mass of 44 grams per mole. And grams per mole also is written as 44.0 U. Now, you may have seen an older unit in your chemistry. Sometimes they will write it as 44.0 AMU, which is an older way of reporting it called atomic mass units. So the atomic mass unit, which is usually abbreviated just with a U, is really by definition, the mass of one carbon-12 atom. So you can see here we have written up here, one atom of carbon-12 is exactly, 12 units, I didn't say that right, 12 atomic mass units. So really 1 U is equivalent to 1/12 of the carbon-12 atom. And that is what it is in kilograms, 1.66 to the power negative 27 kilograms. That's an approximate value. In part B, we're asked to find the mass in grams of 3 moles of carbon dioxide. And hopefully you also recall this in chemistry class. The mass can be calculated by the number of moles multiplied by the molar mass, which is in grams per mole. So the mass is equal to the number of moles multiplied by the molar mass. If you want a formula, you could write it as M equals N times a script kind of capital M. So that would be, we have a total number of moles. This is not a, sorry, I made a mistake. It should be capital N. It's actually a small n, lowercase n, because the capital N actually stands for the number of molecules. A small letter n is the symbol we use for the number of moles. So here we're given 3.0 moles, and we're going to be multiplying by the molar mass that we obtained earlier, which is 44.0 grams per mole. You can see the moles will cancel out, and we'll get an answer in grams. And so our final answer here is 132 grams. That's how many grams of carbon dioxide there are in 3 moles. And that's about it for this example. But I'll just do one little quick aside here. One thing you can often be asked is to find the number of molecules as well. So the number of molecules is related to Avogadro's number. You should have learned that in your chemistry class. It would be taking the number of moles and multiplying by Avogadro. So if we had 3 moles, it would be 3.0 moles, and then multiply by Avogadro's number, which is 6.022 times 10 to the power 23 molecules per mole. And this gives you an answer of 1.81 times 10 to the power 24 molecules. This wasn't asked, but it's a good thing to know. Okay, that's it for example number 1.